Peels, and this is another edition of 3D Printing News Unpeeled, thanks to 3dprint.com. So today we have some news. Chemical Insights, which is kind of a part of Underwriters Laboratories, or UL. It's a company that kind of certifies a lot of things, a lot of safety testing, that kind of thing. And they have worked together with Georgia State University School of Public Health to measure some emission studies on 3D printers. Now, some of these emission studies that have been done before were actually not executed very well and seem to have had like conclusions that are kind of a little bit like, it's akin to a frying pan or something similar to that. And they haven't really been very conclusive or very convincing, essentially. This one is done at least by some very, very credible people. And it's looked at measuring these things in a high school and a university kind of setup for just a 3-hour print. They tested or they measured printers of printing PLA and ABS, and they found that the emissions from these things may trigger cell injury and inflammation. And there was something called a 49% reduction in cellular viability on their little assay there. Generally, we're going to find a lot of stuff like this, and it's going to be really difficult to prove what these emissions can do and if they're bad or not. And I think there's going to be debate about the study as well. But I think we have to really admit to ourselves that these emissions are probably harmful. And also, we don't know what additives are in a lot of the filaments we use. So just to be on the safe side, we would probably all need either enclosed printers or enclosures or some kind of a setup that filters the air. I think that's the only logical conclusion to this and other studies. Like, think about, like, for example, everybody's using TPU now. What's that? All the studies I've seen so far on this kind of emission stuff is on like PLA and ABS and stuff. What about TPU? This is a material that I think is very high risk. And there's other materials as well, like HIPS, that is not used a lot, but is being used. There's other materials that could become dangerous because they have kind of carbon fiber and other materials in them. It could be, if that's exposed or released, could be harmful as well. And just generally, I think we need to realize that as employers or as educators, we definitely have to put these things in enclosures, because you will not know now what printer filament you're making 4 or 5 years from now, what printer filament people are using and under what conditions and what it's certified for, that kind of thing. And I think really the only kind of adult action we can take as an industry is to put every FDM printer in an enclosure. I think we really need to do this. We really need to realize that, because I'm not really interested in being a canary in a coal mine, and I hope you don't either. And I hope you don't want the people that work for you or work with you or your friends to be canaries in the coal mine either. And the evidence is mounting that we are. Okay, the next news, a little bit more hopeful, is E+. So E+ is a Chinese 3D printer company. Together with Farsoon and Xi'an Bright Laser, also known as BLT, they're the 3 Chinese companies that all engage in powder bed fusion, and they're the 3 most ambitious Chinese 3D printing companies in the industrial sphere at the moment, those 3. And also, well, okay, there's other industrial companies that are very aggressive as well, like Kings and all these guys. But I mean, these are the guys that are really expanding internationally and trying to take on AOS and 3D systems at their own game directly, rather than avoiding interactions with overseas 3D printer companies. So, and now they've joined the laser wars. So at 3dprint.com, we always talk about the laser wars, and we always talk about how we've gone from quad laser printers working quite well to all of a sudden everybody doing 9, 10, 11, 12, whatever laser printers, which of course will make the printer, the software, and everything much, much, much more complicated. And it's kind of an arms race. It's an arms race in the sense of the number of lasers and the productivity. It's an arms race to reach these new space clients, which are demanding these kind of big printers, because they want their propulsion units and the bigger parts of their propulsion systems to be 3D printed. So they really need these really, really large parts. And it's a chance to win these customers over, and the real business that is coming from these really, really large parts. And it's also kind of an arms race between countries, because especially in China and the US, they really are trying to stimulate these kind of large printers to make parts for rockets and satellites and all sorts of important stuff. And the Chinese joining us is quite new. They usually are thought of as clones, or the people that cloned M270 printers or concept laser printers, and have then built on the back of that. But now they're really getting into really sophisticated systems, or at least this one seems very sophisticated. And the news here is that ePlus has said at release, or before the thing is actually officially released, that they've already sold 3 of them to one aerospace company. So this printer is called the EPM1250, and it has a 1258 by 1258 by 1350 millimeter build volume. That is, according to the company, 2 cubic meters around of build volume, which is, of course, immense. It's a 9 laser printer. It has optimized gas flow through the wind field, which seems to indicate some kind of optimization around the soot and all the other stuff, which, of course, soot is already a problem. And then all of a sudden you've got those lasers crossing each other, it's going to be a bigger problem. So this wind field improvement seems to be kind of important. They claim the printer can do 240 cubic centimeters an hour, and it works in titanium, aluminum, miraging steel, stainless steel, and the super alloys we all know and love. Another thing that I think is important of this is that the ePlus has said they made their own software to manage this thing and to do the planning and all that kind of thing. So, we are seeing, especially with these 9 laser kind of things, a lot more software involvement, a lot more, it's getting more difficult. And software is becoming something that you need to make yourself almost, right? So that's, I think, a very important kind of little detail. So we're already saying, like, right now, so, what are we thinking here? Is the ePlus printer going to sell a lot of these internationally? Are they only going to sell them to China? How does it work with like a space company? What printer can they buy? Can they even buy a Chinese printer? Is that smart, right? What happens like ITAR registered kind of businesses and things like that? And these kind of defense related or defense adjacent companies, are they going to steer clear of these? I would think so. But other companies may be in the market for something like this, or will this just be a Chinese printer for the Chinese market, where it's going to be very different than what we used to be, because now there's a lot of defense and secrecy and kind of geopolitical implications in our market that we didn't used to have. Used to be we were just a machine tool, and there's no big deal. And now people are looking much more kind of, less friendly at everyone else, essentially across the world, due to all these geopolitical concerns. So, watch the space. This is going to develop, and it's ongoing to see if these systems are worth it. It's ongoing to see if these systems are going to be reliable enough to print things, reliably day in, day out without failing. Imagine a thing failing in 150 hours into the print. Imagine what that'll do for your customer, your own timeline, all that kind of thing. That kind of thing could be very, very difficult for these guys. So we have yet to see if these things really prove themselves, and to see if there's going to be a shakeout, really, essentially. If there's going to be only a couple of firms out of like the 10 firms that do fan-to-bed fusion, maybe only 2 to 3 can do that reliably with more than 4 lasers. Right, that could be a real shakeout. That could really divide the market. So watch this space. The next bit I think is really, really exciting, because it involves SwissTo12. SwissTo12 is one of my favorite all-time 3D printing startups. It's a Swiss company, and they make space, mainly satellite components, mainly RF components, radio frequency components, waveguides, that kind of thing. And I loved this because especially in this particular market, what we can do is it's kind of the ultimate kind of business case for 3D printing, because we can make things that are actually cost competitive with what's available in the market right now. We can actually, in terms of RF equipment, we can actually get stuff that performs better than anything else, and a better waveguide than any other one. We can reduce the production steps. We get a better buy to fly, of course. For these guys, there's something their internal measurements always in swap and stuff like that, and that's really good with us as well. That's how these RF guys look at it. We can also integrate components, so we can go like I think there's certain parts on the SwissTo12 product lineup where they're going from literally thousands of components to dozens. Right? That, of course, is a big reduction. We can be more flexible. And we can also do kind of like we can integrate functionality. So a bracket could be a heat sink, could be part of the waveguide itself, for example. So there's a lot of advantages. And then, every little bit of mass we squeeze out of this thing, of course, is going to be fantastic. We can make it more conformal. We can reduce assembly time at the customer site. And that, of course, is really expensive because it's like a kind of clean room type of thing. So this is absolutely really wonderful. And SwissTo12, along with Optisys, is the only real company that's pure play was doing this. And now SwissTo12 did something. It's not like this happened suddenly. They announced something, I think it was about a year ago, something working with ESA, the European Space Agency, on the satellite project, which was later called the Hummingbird. And they have now sold their first actual complete satellite. And a lot of the components on that satellite are 3D printed. So on the one hand, wow, there's not a lot of companies out there that make satellites, and all of a sudden these guys are using 3D printing very intensely to print satellites. It's really wonderful news. But I'm just thinking, like, isn't SwissTo12 doesn't have the best business model in the world already by making the things on the satellite that are the most valuable for 3D printing? They're relatively compact objects as well. So the revenue per density, or the revenue per print cubic centimeter, is very, very high, right? It's a relatively compact object. So don't they already have the best business in the world? And are they now messing it up because they're now going to make satellites? Now, satellites itself, there's some studies that say it's going to increase by 4,500% in the next couple of years. So that is a huge boom, right? There's people using satellites to, like fleet space stuff, using satellites for mining and to map the world and to really do a lot of research-oriented stuff. There's other people that are using satellites for communications, that want their own internet networks, that kind of thing. There may be a global IoT networks and sensor networks. There's more communication, that kind of thing. More bandwidth generally for the internet everywhere. So yeah, it's a boom, boom, boom time for these guys. And to me, up until now, SwissTo12 was enabling all these other guys by making these components, and now they're just a satellite player as well. So is that going to go well together? Are they going to continue to be able to sell these components to people? I don't know. But I think that this is actually, no, it's very exciting. Now, the satellite thing itself is also really exciting, I think. So it sold its first satellite to Intelsat, a really large operator of communications and kind of TV kind of satellites. And this is going to do, the satellite's going to be launched in 2025, hopefully, and it's going to be a geostationary orbit satellite, and it is a tenth of the size of some of the other satellites being used for this, notably older, and it is approximately about 3 times or so cheaper, the company says. So those are some incredible figures. Imagine also a passenger car coming out that, well, that's a bad example maybe, but but just generally, I think, we're talking about something that they could be revolutionary. And I think I love SwissTo12 as a company. I think they're fantastic. It's very difficult as a journalist to kind of find information on them, to get them to talk about anything. But I think it's a really, I'm a huge fan. I think what they're doing is fantastic. And yeah, it's just a little bit of a thing. It's about a thing for maybe you to think about. What would you do? Would you like to be the component supplier that supplies these tip of the spear components, the very important things that are very, very profitable with 3D printing? Or do you want to just build the whole satellite and be one of the very few companies that make satellites in a time of a satellite boom? It's one of these things I don't think we'll ever know the answer, but to me, it's like, it's a hell of a strategic decision, a hell of a strategic little gamble or thought experiment to go to. So that was the news for today. And my name is Joris Peels. This is another edition of 3D Printing News Unpeeled. And this is thanks to 3dprint.com. We hope you enjoy this. Share, like, tell all your friends about it.